And that still applies. Make sure when you have high availability, everything matches, your hardware matches, the same blades, the same everything. If on A and B, whatever, they must match. And obviously your TMOS versions must match. Everything's got to be the same. So the two types of mirroring we referred to a few times already as connection mirroring and session persistence mirroring. Connection mirroring deals long-term connections such as think FTP or maybe SSH. When you SSH into a box and it fails over, do you want that to persist? If yes, you set up connection mirroring, and you do that within the virtual server itself. Session persistence mirroring has to do with typically like a shopping cart application. So a customer is shopping, they're clicking, buying items, now they're ready to check out and pay for it. And at that moment, that guest, let's say, goes down. Do you want that to persist and fail over to the other guest, to the standby guest? If yes, then you set up session persistence mirroring, and that's done in a profile. So the first one, connection mirroring, is done in the virtual server. You click this under advanced setting, you click this connection mirroring click, and notice the system gives you a little heads up. This may degrade performance because it's got to keep track of these long-term connections on both your systems. And then the persisting is done in a profile, which in this case under mirror persistence, you just click it, check it, and then you assign this to your virtual servers. This has to do with the DAGs. A DAG is a disaggregator, and what we're saying here is that the DAGs, then our aggregator is a component on each blade has its own DAG, and they do load balancing to the TMM. So it's kind of on a hardware level. And so in this case, we have a switch connected to a trunk, connected to a switch. And when this goes over to blade 1, the DAG will look at the TMM that's modelable, whether it's on its blade or not. And DAGs keep track of the TMM. So if, for example, the switch is going to send it to blade 3, and that DAG, but that DAG, the blade goes out of service, then sends it to blade 2's DAG will update its table, letting them know that these TMMs associated with blade 3 are no longer available. And likewise, when you add a blade to the system, the DAG table will update and let them know now we have more TMMs available. DAG, the disaggregator of the TMMs, which takes us to. So we're going to go into a little more detail of the 2000 series components, the 4000 series components, take a look at some key options, look under the hoods a little bit. Starting with the 2200, we got a system ID enunciator card over here in the upper left. I have a photo of it coming up. And power supply, fans, and has up to 2 blades in it. As far as the power supplies, this is pretty much true of all the different models. They're auto-ranging, auto-distributing, so they're constantly actively sharing and distributing the load, so no one power supply is taking on the whole load. They're sharing it. And typically, like in a small box like this, one power supply can power both blades, so that in the event you have 2 power supplies, one goes bad, the other one could still power the box until you replace the other one. And fan trays have variable fan speed. It is a user replaceable box, just like the power supply, so you can swap it out. One thing I will tell you is that there's a 30-second window. So here's the story. Let's say this fan tray needs replaced. You get some errors in your log saying fan trays went bad, get another one. Don't pull out the bad one, the defective one, until you have your replacement one ready to go. In other words, don't pull this out and then go looking for the replacement and seeing it's in a box, open the box, pull out all the popcorn. No. That's not how you do it. You go to your replacement one, get it all ready, have it on the same shelf, ready to go, and then pull out the defective one and shove in the new one. Because if not, then you're going to take one bad problem and make it worse. The system's going to overheat once you open up that, pull that tray out. So, yeah, user replaceable, you got a 30-second window to do that. these individual fan units, fans can, if one of them slows down, the primary blade, that's one of its roles, one of its responsibilities, it'll actually speed up some of the other fans to compensate for one of the fans that's slowing down. All right. And we got the 2400 chassis that we've been using today in class. And once again, 2 power supplies. They're auto ranging, same thing. 1 power supply can power the whole box, but you always want to have 2 in there just in case one goes bad. And likewise with the fan tray, same thing. User replaceable. You got a 30-second window, and you got a LED on the back here. Let you know if something's wrong with it. And here's that optional USB LCD. So this LCD works just like a standard appliance one. You know, it's really handy for troubleshooting to find out what version the system is, to set IP addresses not only of the cluster but each individual blade. You know, it's a real handy thing. One of the pros is that it's optional, and some customers, you know, purchase it without the option, and then when you need it, a few times you need it for troubleshooting, you know, it's not there. So it is, you know, check it out, see if you have one, and here's how it works. You plug in USB into the primary blade. As I mentioned, you can look at the LEDs of a primary blade and just plug it in there, and then go ahead and use it. How I've used it in the past is if I'm not sure of an IP address of a particular cluster or a particular blade, this thing just walks you right through it, how to set an IP address. Change it, view it, what version the system's in, or whatever. Real handy. So it connects via the USB to the primary blade. This bullet's kind of interesting, no accessible memory. In other words, if someone steals it, aha, I got the F5 thing here, and they plug it into a PC, there's nothing there. Okay? So it gets all the information from the primary blade. But how we typically use it is we show or change a cluster IP address or a specific blade. So they're handy to have, but it does not come with the 2000 series. It is an option. So here we look at the different blades. We used to sell the 2100. It had 16 gigs of RAM, a 300 gig hard drive, 8 SFP plus ports, and then we migrated up to the 2150. We doubled the RAM, 32, increased the disk drive, went from hard disk to SSD drive, and 8 SFP ports. Today, we ship the B2250, which has 64 gigs of RAM, 800 gig solid-state drive, and 4 QSFP plus 40 gig ports. So 4 40 gig ports. We talked about, you can, the default is unbundled, 10 separate 10 gig, or you can bundle them as 40 gig. And here's a blade summary with the different blades, just to show you kind of how they've evolved over time. Increase the memory and the processors and the disk storage as you would expect. This is the module that plugs into the blade itself, and this QSFP Plus module plugs into the B2250 blade, I should say. And it's a standard MPO MTP interface. However, it is F5 branded. So if you want F5 support to support it, you got to purchase this particular transceiver from F5. And the cables, if you go unbundled with it, which is the default, this plugs into the transceiver that I just showed you and is into your switch, LC duplex connectors. Or if you go straight through, 40 gigs on one end and 40 gigs on other, then you just straight through. The one on the left is an F5 product. It must be purchased from F5. The one on the right is off the shelf. You can buy your own. And it's just more of the same, straight through or breakout. Whoop. And there's that photo once again of our actual 2400 in our lab here with the 4 separate 10 gig interfaces, 2 LEDs each. Then it takes us to the 4000 series, 4480, 4 blades, and it's got its own fan tray on it. It is hot swappable. Once again, the 30-second rule applies. Power supplies, vary in these models depending on how many blades you have, but typically you want to have 2 or 3, and recommend that it can have up to 4 power supplies. They do auto sharing, auto distribute the load, and so if one goes bad, you could still run the system with the other models. So you want to check with the data sheet to determine how many power supplies you need for these bigger models, depending on how many blades you have. And here is that annunciator card. I told you I had a picture of it. It goes into your system. It's covered up by that plate. So it holds your big IP license, terminates on the back plane, connects to the front bezel. It's not hot swappable, not. And in the high end, the 4800, we actually have 2 of them. Okay? So in that case, it would be hot swappable in the 4800, but in a typical model, it's not. I've talked to engineering about this. They say very, very rarely do these things ever go bad. The only time they've ever seen them go bad is in their beta systems, where they're constantly, powering them down and swapping out parts and stuff, and occasionally these go bad. But in a typical production system, they don't typically go bad. And we got the bezel, so unlike the 2000 series, the 4000 series standard, which is nice. Our top of the line, our C4800, it's got 8 vertical blades, so they're kind of put in vertical, and then the fan does something interesting and kind of sucks in air from the bottom and runs it up over blades, and then it goes out on top, and there's a filter in here. And when the filter needs changed, the logs will let you know that. It's just worth it.
Where do filters come from?
I don't know if it's an F5 or if it's a standard filter. I don't know that for a fact. We'd have to check that out. I'll just jot a note, see if it's in the hardware guide. I'll check on the filters for the 4800, see if it's in.
I was just curious how often they have to be changed and whether or not you can keep them on hand, like keep one on hand?
Oh, yeah, that's what we recommend. Question is, are they off the shelf, or do you have to buy them from F5? And I'll check that out for you.
Okay.
Yeah, you definitely want to have a couple on hand. And this just shows you the evolution of the different blades with the 4100, and then we've doubled the capacity in the processor, and this is what we sell today. So if you have the 4000 series, you purchase the 4300, and if you're NEBS compliant, you get the 4340N blade. Dual hex-core processors, 48 gigs of RAM in the 4300, and double that in the NEBS compliant. 600 gig hard drive, it does hardware compression, and it's very state-of-the-art. All the components are covered pretty much. And this is just more of those QSFP interfaces. All right, and this is the 4000 series blade summary, once again, just to see how they have evolved over time. You do have a copy of this in your student guide. Viprion data sheet is really handy to have. It gives you a lot of nice specs on all the different boxes that we sell and all the different blades for transactions per second and how many power supplies you need and all that kind of stuff. Real handy, and you can get that from f5.com. The other thing I want to mention about chassis and blade, I probably mentioned it's worth repeating, is that if you have a 2000 series chassis, you need a B2000 series blade. If you have a C4000 series chassis, you need a B4000 series blades. Also, no mixing and matching of blades within a chassis. So if you have 4200s in a chassis, that's what you want, And likewise, no mixing and matching of blades within the same model. So if you have a 2400, whatever, you got it. All the blades must be the same. And it is, when you think about it, that one of the tasks, responsibilities of the primary blade is to copy its configuration to the other blade, right? So if you have 2 blades that aren't the same, something's going to go wrong, very wrong. All right. So no mixing and matching of blades. Take a look under the hood a little bit at the, we have a fully interconnected backplane, passive backplane. We have a HSB, high-speed bridge, a DAG, I've mentioned, a disaggregator, which is a load balancer for the TMMs. We have a CAN, control area network, and an SPR, serial port redirector. So let me just show you this in a kind of a graphic thing. This is a blade here, and from the front panel port, sends a request into the switch. The L2 switch goes to the DAG. The DAG will determine which TMM gets this particular request. In this case, it goes to the HSB, the high-speed bridge, and says, okay, we're going to send it to this CPU is going to process this request. Request comes back out through the same, to the HSB, out to the DAG, to the same switch front panel port, back to the client. Next request comes in, L2 switch goes to the DAG, and this time the DAG says, you know what, this TMM is going to go off board. So what it does is sends it to a different switch and goes out the back plane. And let's say this is blade 1, so it goes out the back plane from blade 1. Now it comes back into blade 3, let's say. So let's say this is blade 3, comes into the L2 switch of blade 3, and then goes into the HSB, says, okay, this CPU is going to process this request. After it processes the request, it goes out from the L2 switch back to the back plane, back through the back plane, down, back to where it came in blade 1 in this example, hits the L2 switch, and goes out the same front panel port it came in on. So the point is, this DAG is the disaggregator. It determines which TMM will process that request, whether the TMM is on board or somewhere else, or on a different board. Alrighty. So think of a DAG, the disaggregator is the load balancer of the TMMs themselves. So what you want to make sure is all your blades are cabled to the network so you don't put too much pressure on one DAG in one blade. We also have a CAN, a control area network. It's used for command and control signaling, what I call low-level information between blades and fans and your annunciator card, your health. It's got temperatures, voltages, you know, all that kind of stuff. And you can have two CANs on the high end, the 4000 series, only one on the 2000 series. And you can actually capture some of this information using TCP dump, capturing for SL0 and SL1. And we also have serial port redirector for out-of-band management. We can jump from one blade to another. I'll show you in the next module. We have a lab on that. This just shows you the system backplane where there's multiple fabrics and they have multiple CANs. In this case, we're just talking about the CANs. CAN 1's going to the fan tray, CAN 2 is going to the power supplies. So we have lots of levels of high availability, of redundancy, and it's all done over this passive backplane. All right, so I got a couple questions for you. There is no lab in this module, so I put together a couple of questions. And what I thought we would do, instead of shouting out the answers, which we typically do, what I'm going to have you guys do is send me a chat when you know the answer. You determine how many blades in the 2000 series and 4000 series Viprion can have. How do you know? Yep. 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 Everyone got it. So the answer is, as you guys are texting me, second digit. So for example, the 2400 we're using today can have up to 4 blades. We have 2 in ours, but you can have up to 4. Excellent. All right. The cluster automatically selects a primary blade. What are the other blades called? Secondary blade. Yeah, the quorum process selects the primary blade, and all the other blades are known as secondary blades. If you see a yellow blinking LED on a blade, what document should you consult? Good. Hardware guide. All right. Platform guide. Yeah. Most people don't get that, just so you know. This is the single hardest question in the whole bunch. But yeah, it's really good that you guys are aware that for each model of Viprion, there's a platform guide, and in that guide's got all the LEDs you could ever think of. Any combination of this is blinking yellow and this one's flashing red, you know, all that stuff. You don't need to memorize it, just look it up in the book. Good. True or false, the system enunciator card is hot swappable. False is good. Good. The exception would be in the 4800 has two of them, so, but for most cases, yeah, it is false, yes. Okay, a fan unit is hot swappable, so when replacing a fan unit, you must install the replacement fan. Everyone got that. I like D better, but the answer is A. All right? So you got to have it ready. That's my point. Is don't have it in some box somewhere and you got to go look for it. Have it ready to go, and then it's pretty easy. It's 2 thumb screws. You know, it's not much to it. All right, one more module: maintenance and troubleshooting. There is a lab on this, and this is the lab, as I mentioned, that you do some blade jumping, which is pretty cool. And in this module, there's a lot on Viprion indicator LEDs, and I'm going to kind of skip through that piece of it for a couple of reasons. One is, you know, we're running a little low on time. Two is, as long as you know that the LEDs provide valuable indications of the system, and you know where to look in the platform guide, that's really all I need to know, because you know, I've done a survey of you guys, the students, and most of you never even see the Viprions. Most of you are in a different building, a different city, whatever, so you never get to see the LEDs anyways. But as long as you know, if someone says, hey, there's a red blinking light, what does that mean? And you know, obviously yellow and red are not good necessarily, but you want to look it up in the book and check your logs, and it'll tell you what it is. All right. So with that, then, let's go through this. Cluster synchronization, when you add a new blade, takes about an hour. So you shove that blade in, and it looks like the system's doing nothing, but it's actually copying the configuration from the primary to the new blade. And why it takes so long, have you guys ever downloaded an ISO from F5 downloads? If so, I'm sure most of you have. It takes time, right? And then now this thing's doing it, from one blade to another via the backplane, and it just takes time. So it takes about an hour. So when you insert a new blade,
Gary, is there any possibility when you insert a new blade and it pseudo comes up but hasn't checked all the VIPs and pools and everything, that traffic could inadvertently get sent there before it's fully ready and functional to take traffic?
No, I don't think so. I think it's got to get fully configured, fully synchronized first. It's got to go through that cluster synchronization process before it starts processing traffic. Yeah.
Okay. Thank you.
Yeah. And you could follow the LEDs on it too. You know, when the LED turns green, it'll start processing traffic. So when you insert the new blade, it checks for power. If it can't boot up, you'll get a yellow LED, and the other blades will blink and just won't boot. And what you want to do is check your logs, var log LTM. And remember, it does take time, but if it's over an hour or so, you might want to check your logs and get on the phone with F5 and see what happened. We got some Viprion commands that you'll get to do in the next lab coming up, which are pretty cool. So this is the blade control command. It allows you to do tasks on a specific blade. You do a blade control -B, put in the blade number, and then whatever action. Typically what you're going to do is R -R, reset a blade, for example. It would be a good use of this command. Cluster shell command, you can execute a command on all your active blades from one command. So you do a CLS, cluster shell, and what options there are, you do a -help, and it lists them all. 2 examples, you can do a cluster shell big start status on all your active blades, or you can show your net interfaces management on all your blades just by one single command, so it's pretty cool. Under /VCMP, you can list your guests, show them, list your virtual disk, show them, and then show global, which is kind of everything on VCMP. So a lot of good VCMP commands. And then under sys, we probably mentioned this one earlier, you can modify your cluster default IP address just by this one here. You can list your cluster, show cluster, all your properties, show your HA status, or show hardware. If you've ever done a show hardware, you got everything you need to know about the temperatures, the voltages, just revision, firmware, just tons of stuff. And that's a good one. And then here's my favorite, blade jumping. So if, for example, you got blades in slots 1 and 3, like we do in our class, and blade 3 just isn't cooperating. It's misbehaving for whatever reason, sending you some errors, logs, you can't access it via the IP address. What you can do is do blade jumping. So what you do is SSH one slot to another. So for example, in this example here, we SSH to blade 1, okay, and then we type in this command, SSH space slot, in this example 3, hit enter, boom, it has you log in, and you log into blade 3. And then from there, you can check the logs, you can reboot it, you can list var core, if there's been any core dumps in there. This is the kind of thing that you would typically do once you blade jump from one blade to another. Typically, you're going to try to reboot it. All right, so that's a good one. It's a handy one. And then when you're adding that new blade, if it doesn't respond, check the LEDs. Remember, the LEDs during power-up sequence are different than if they're processing traffic. BIOS firmware upgrades may cause a reboot. Remember that image copy is very slow. It's across the management plane. It just takes time. It just takes about an hour. But if it's been over an hour and you're still waiting, they might check the logs and maybe call up F5 support and see if something went wrong. Okay, this next section is all about the LEDs, and I told you that you can get valuable information from the LEDs, but most of you guys never even see the box, and you know where to find the LED information in the platform guide, so I'm going to just ignore all this stuff, okay? And these are, LEDs do provide real good information. If you didn't know, you can define custom alerts that change the LED indicators. So you can user alert comp setting. You can define your own custom alerts. We have an example here. So the front panel will indicate a warning when a pool member or node is down by customizing your own alert here. It's more good to know. And this is a neat page. This is right from the GUI. You can do some pretty cool stuff here. Right from the cluster properties on the bottom. We didn't show you this, but it's nice to know you got your cluster members, and then the GUI tells you the status of them all. It looks to me like this one is red. Someone pulled that blade out and shoved it in another slot, And here's another thing. Let's say you needed to remove a blade for maintenance, but it was still processing traffic. So you wanted to kind of drain it, So what you could do is click this the check mark next to that slot, and then do disable yield. It'll actually drain all the traffic from that blade until it's clear. And then you can just yank out that blade without disrupting any traffic. So that's a good one to know, right from the GUI. And you can do a similar thing, take a look at a similar type thing from the show sys cluster. Gives you, a status of all your different, on the bottom here, all your different blades, how they're doing. As far as TCP dump, as you know, is a valuable tool, and there are some options in there for Viprions. And so I've identified a bunch of solutions that have that, and they're also in your student guide on page 211. These solutions are listed, so if you want to later on take a look at some of these. And another responsibility of the primary blade is to aggregate the logs from the other blades, and that's what you see here. You got, let's say the primary is 1, it's got some logs here, and we've got some logs from slot 2 as well. So it's going to take many of the logs and aggregate them. However, some of the other logs are not aggregated. Things like kernel issues are local, hard disk drive issues are local. So it does not aggregate all the logs, just some of them. So some of the logs you can tell just from looking at the primary, but some of the other logs you actually have to go into each individual blade and pull out kernel issues and hard disk drive issues.
That includes all modules, Gary?
Does that include what?
AFM, AM includes all of them?
Yeah, yeah. So you want to log into a specific blade and check that particular log out. Yeah. So yeah, some will be aggregated and some will not. So your best bet is check out your primary logs and then go into each individual blade for some of these other ones. So best practices, make sure all your management port are wired, management IP on every blade, as we talked about. All your cluster members should all have a management IP, even if there's no blade in that slot. Aggregate your links, we call them trunks for configure NTP. Have your multiple serial ports for a serial concentrator. Utilize HA VLANs between chassis. And we talked about the different mirroring options as well. We talked about QK It's no longer appropriate to run one on the host. If you have guests, you got to do one on the host and one on each individual guest. We recommend not only doing it for troubleshooting, but what we recommend at least periodically, let's say once a month, run a QK view on your system so that you have a baseline. And here's what I mean. If you run a QK view when you get back to work today or tomorrow, and you save it, okay? And if you have VCMP, do it on one on each individual guest. And then later on, let's say a year from now, you run into a problem where everyone's complaining how slow your system is, and you call up the support center and you say, hey, things are running slow today. And they're going to say, slow compared to what? This way, if you have a baseline and you've saved your QK view from a year ago, you pull that out, send it to F5 support, and now when they run a QK view today, they have something to compare it to. So that's what I mean. It's real important that you get in the habit of running one of these, I'd say once a month, okay? And this just walks you through how to do it. You do it right from the GUI. You click Start and download it, and you log into iHealth and you use Upload, and then you take a look at the status and go through all the different menu items here. And what I want to show you is they do compensate, for Viprions. They have, for each blade, you got QK view status heuristics for each blade in the whole appliance itself. But look at the kind of information it gives you and gives our support. The BIOS revisions, your RAM, it's just tons of serial numbers, chassis number, your DAG models, it goes on and on. This is the kind of information that our F5 support uses to troubleshoot your system. So think of them as baselines that you want to take periodically to save them. So when you do, in the event you do have to call up F5 for support, you have all these in your back pocket to show F5. Okay. And oftentimes what shows up here is they refer you to a solution to solve your problem, to enable yourself to self-solve your problem. And we the iHealth group here at F5 updates these heuristics every week. It's just a sample of some of the latest ones that we got from our iHealth department. And when you call F5 support, these are the kind of information that they need. System serial numbers, problem description, and all that information you get from your QK view as well. And if you've never called F5 support, I doubt if any of you have never, but if you have never, there's two solutions that you should probably read and get prepared for first for the kind of questions they're going to ask you. Okay? And you all know about Ask F5. And here's that solution, tells you how to call in for support. And the last thing we'll talk about is EUD, end user diagnostics. This is when you're deep troubleshooting hardware stuff. And you never want to run this on your own, just for the heck of it, to run EUD today. No. This is when you're on the phone with F5 support, and they're kind of walking you through this, trying to identify a specific hardware troubleshooting issue. You never run it on a production system. Before you run the test, you disconnect all your cables. And before you run it, you remove all the blades except for the one you're testing, and you only run one instance at a time. So you would never do this on the fly, only under the assistance of F5 support. When you do through which version is the and then how to download it, typically using a USB, and where to load it, and all that kind of thing. So this is all stuff that you would get from F5 support. And these are the different tests that EUD runs, and they would tell you which ones to run to try to resolve your particular issue. All right, that takes us to the next and last lab of the day, and it's on page 618 and 619 of your student guide. And what you're going to do is you're going to have a GUI,